I want you to look at these devices. Now, I've been talking to the engineers here at KABC, and these guys all know their electronics very well. They keep ours shining and going all of the time. What we do is a violation of a lot of their physical laws and properties that they work by. So the engineers here are very interested. So, Michael, you're a part of the show.
Michael, come here just for a second. I want you to see something as an engineer, okay?
Now, he didn't know he was going to do this.
Here's a compass. I want you to check out that wheel and tell me that there's a north. No, don't start the wheel. Just check the polarity of what those magnets are. And make sure that there's not one in the wheel that's not indifferent. Okay, they're all the same polarity, right?
Let me turn on that microphone over there, Mike, so you can get on, because you're a guest on the show, so you don't have to worry about your...
Okay, Mike, what I'm going to do...
They're all consistent.
...is I'm going to hook up this battery, okay? And these two are generator outputs, okay? And what I want to do is I want to hook up this battery. If you wish to get a meter, you're more than welcome to do that. I'm going to hook up the battery. Here's the positive. Here's the negative. Now, notice that there's no movement in the device whatsoever, but you have all the pulse. So what we do with this type of energy device is, if we want full power out without drawing anything out of the battery whatsoever, we have a little light that's equivalent to what the wattage draw of this particular motor is. Do you also notice that there's only one pole on this motor? Is that correct?
That's what it appears to be anyway. Sure.
Okay. Now, what I want you to do is put this switch down in the start position. Just push the switch down. Okay, and give this a spin towards you. Now, this is at a constant current. If you had a meter on there right now, it would be at a constant current, okay? Now, what I want you to do is put this into the charge position, push the switch up, and if this speeds up, it must mean that the battery is getting more energy. Go ahead.
A slight increase there, yeah.
Well, let her go.
And getting faster.
And getting faster.
So we'll just continue to let that device run, Bill.
All right. It's a monopole.
About 4 hours.
Okay.
Michael Kelly, engineer. Is that define
speeding up?
Your idea of what energy should do?
Well, I'm the wrong guy to really be asking about all this, Bill, but it appears to be
now,
as simple as it looks.
Let's take some energy
working
from that, okay?
We have an impromptu demonstration going on.
I have a little bulb here that's a number 47 bulb, which is equivalent. By the way, this motor right here is running on about 0.128 milliamps. And see, it has plenty of torque here. And what I want to do is take it out of the charge condition, because I want to supply power now somewhere else without any drain here. Okay? So I take it out and I supply my power to where I want. That meanwhile, that keeps running. Now, if you put this switch back into the charge condition, I will send it back to the battery.
Interesting.
And it will speed back up.
Just amazing, Bill.
I have to apologize to Mike Kelly, who is our engineer here tonight, who keeps us going. He did not know that he was going to have to come in here and look at some electronics.
There's a very unique thing there. That motor is being driven by all the same type of poles.
And not only that, it's spinning a 7-pound weight.
Pretty good.
Yeah, it's pulling 7 pounds worth of mass for less than 1 watt of input power. And still speeding up.
Mike's eyes are as big as a saucer over there.
It's okay.
I'm convinced on this part of it. Anyway.
You're convinced there, are you?
Yeah, I'm impressed.
Well, guys, I want you to put on your earphones, because we have another guy on the phone here. Mr. Thomas E. Bearden, who is one of the more advanced theoretical physicists in the world. Tom, welcome aboard.
Hello, Bill. Nice to be back with you.
Where do we find you tonight?
Well, I'm sitting someplace in Dallas, Texas.
In Dallas.
I'm not sure just exactly where, but I'm sitting someplace in Dallas, Texas.
Well, we're sitting at a studio in Los Angeles. We've got free energy devices going crazy here in front of us. And, of course, your friend and mine, John Bedini and Steve Worth, are here.
Oh, boy.
And, the technobrats have descended upon us in full measure.
If you've got those two guys loose again, no telling what's happening.
Well, they drove me down here tonight. We got here in 20 minutes. I don't know whether we went through some sort of a time frame or whatever, but with those two, anything can happen. Have we got free energy, Tom?
I have not been able to see that device. I was listening very intently there. I just came on the line a while back, and I was listening to the description there as they were winding it up. As best I understand what you've got, with all the poles the same polarity, I would say you've got a very good chance of having it right there. It's got to be it.
Well, we have two different ones. We have this a Richter set-looking pendulum that is not about to stop swinging.
Yes.
And I have seen it swing for hours, in fact. It will drive you crazy with that little plump, plump, plump that it does. But it never stops. And, well, it does stop if you stop it. Well, no, it's not stopping there. Well, it's on the motor right now, so it's kind of wiggling on top of the little motor that's in the middle.
Yeah, well, as I understand, you were taking some energy out, too, at least occasionally there.
Yeah.
So, of course, that's the criterion. If you throw energy out of the system and you keep going, sooner or later you've got to say that you've gotten that energy from a new kind of source, that it's not the conventional sources that are going on. When we say free energy, you know, we really mean that there is some hidden sources. There are some hidden sources in the vacuum. They're like hidden rivers that can be tapped. Normal motors and normal generators do not tap them, but it is possible to build motors and generators that do.
Well,
and we're saying that you build a special paddle wheel and you build a special river. You have to make the river. You make the dam for the river, so to speak. And once the dam is made and the river's flowing, you have to furnish just a tiny bit of energy to maintain the dam, but you don't have to build it again from scratch. And then you have to have a special paddle wheel that'll go in the flow and take that and turn that into shaft power. When you do that, what you've really done is in terms of relativity, you've bent space-time and you're using gravitational field energy, and that's exactly what it sounds like you're doing right there.
Well, this is a form of gravity engineering we're looking at.
See, all energy in the extended sense, all fields come from or directly associated with the curving of space-time. You might say gravitational energy in the general or extended sense. And so all the other energy comes from that as some subset of that. And then really, if you talk about a more obscure kind of energy, you just build a more obscure kind of gravitational field in the theory. And so we can boil it all down to say there's one master kind of field source or energy source, and for want of a better term, we call that gravitational field because there are many, many things that warp space-time. It's not just a single field. It's a conglomeration of a whole bunch of things. And that's what we call gravitational field. And if you get one part or two parts or all of that working, yes, when you warp space-time locally, you've done something that our textbooks have assumed you can't do. And if you do warp space-time locally, we already rigorously know that you can violate conservation of energy locally, where you're at. We're not saying for the whole universe. We're saying where you are. Just like if you stick a paddle wheel in a river, if you only consider the paddle wheel, don't consider the river, you seem to have violated conservation of energy. Of course, there's a source there. In this case, you've created a more subtle source and a more subtle paddle wheel, but it's really at base root level. It's no more complicated than putting a paddle wheel in a river. It's complicated